Hello everyone. Today in our class, in this video, we're going to discuss about dining philosopher's problem in operating system. If at first we will see what is the problem and what is the solution we're going to give using the monitors. Okay. So what is dining philosopher's problem? In the name itself, we are saying that it is a dining and plus philosophers. It means that we have the philosophers which are seated in a dining table. The dining table might be in different forms, like different shapes. It might be rectangle, it might be square, it might be circle, right? But here in the dining philosopher's problem, the philosophers are being seated in the form of a circular table. Okay, so assume k philosophers have been seated in the circular table. So whenever you are seated in the table, so you need spoon or fork or chopsticks to eat the food, right? So here we are gonna place each two chopsticks, like we're gonna place the chopsticks between the philosophers. Okay, so the philosopher will take two chopsticks at a time and he will eat the food. Means how many chopstick it need? Only two chopsticks. Two for eating the food by the philosopher. Okay, so let's see the picture so that we can understand clearly. Okay, I'll share the photo. See here in the picture, there are five philosophers, right? P0, P1, P2, P3, P4, right? So here these five philosophers have been seated in a circular form. And there are how many chopsticks? One, two, three, four, five. Five chopsticks have been placed. So whenever a philosopher P1 wants to eat it, what he has to do? He has to pick up C1 and C2. Then only the philosopher can eat. For example, if P0 and P1 wants to eat the food, what chopstick it has to pick? P1 needs C1 and C2 and P0 needs C1 and C0, right? But C1 is busy with P1. Can P0 can eat now? No, because it has only C0 chopstick but not C1. So now only the P1 can eat but not the P0. So here a philosopher may eat if he can pick up the two chopsticks adjacent to him, right? The two chopsticks should be there. Otherwise, the philosophers cannot eat, right? So here, that is a problem, right? So first, what we will do is we'll try to check whether the both chopsticks are available or not, and we will see whether these chopsticks are acquired by the other philosopher or not. Okay, so whenever a philosopher is being seated in a circular form, first he will be in the think mode and then he will eat, right? So in between them, we have another thing is like he will wait for the chopsticks. He will wait whether the chopstick is whether the chopstick is available or not. Okay, so you have seen the diagram. In the diagram itself, it's saying all the five philosophers are there and the chopsticks are there. Only if the philosopher acquires two chopsticks, then only the philosopher can eat, right? So now we will see the code using the semaphore, right? Using semaphores, we will try to solve it. Like we will try to give the uh, access to the chopsticks by the philosophers, and then after using the chopstick, what the philosopher has to do, he has to release the chopsticks. Otherwise the other philosopher cannot eat, right? So other philosopher, what he will do, he keeps on waiting for the chopsticks. So whenever you complete the food, immediately you will place the chopsticks on the table so that the other chopsticks will eat it, right? Other philosophers will use the chopsticks for eating. So for this purpose, we use the two operations from the semaphores, which are called as wait and signal. We will use these two operations. Now I will share the photo with the code. Okay, the code, you Yes, I hope you can see it. Now see here, the weight of the first chopstick and the weight of the adjacent. Like philosopher one one needs chopstick 1 and the chopstick 2, right? So here if I is equal to 1, I plus 1 is 2 divided by 5, 2 modulo 5, which is 2. So here 1 and 2 chopsticks are needed by the philosopher 1. So why we are choosing modulo 5 here? So for example, if I am taking the philosopher 4, what will be happening here? 4. 4 plus 1 is 5. But there is no fifth chopstick only. So what will happen now? There is no chopsticks in the table only with the fifth number. So to overcome this problem, we have used the code as percentile 5. Okay, fine. So here, first we are acquiring the first chopstick, which is 4, and which is 4, and which is 3, and then 4. I is equal to 3, we are acquire I is equal to 3, we are assuming, and then I plus 1 is 4. So 3 and 4 are the chopsticks needed by the philosopher 3. So once it start waiting for the chopstick. Once it acquired, what it will do, it will eat for a while. Okay, I have gotten the two chopsticks. Okay, now what I will do, I'll not wait for anything. The food is there, the chopsticks are with me. So what I'll do, I'll start eating, right? So I will start eating, and then after eating, what I will do, I will place a chopstick, both the chopsticks on the table. So to indicate that one or to tell in the coding language, we use a signal operation. For acquiring, we use a wait operation. For giving a signal that I am done with the eating. Now I am placing the chopsticks on the table. So for that purpose, we use a signal. Okay, I am placing the third chopstick as well as fourth chopstick. After placing the chopstick, what the philosopher will do? He will just sit idle, like he will be in a thinking mode, right? So now the problem is, if one philosopher is eating, the adjacent philosopher cannot eat, right? So, what is the solution for it? So, we are having three solutions for that. The first solution, the first solution is we can try to make the, for example, as I said, we have taken five philosophers, right? So, I'm just removing the photo. Yes. So at first we have taken five philosophers, right? There are five tables. So what we can do is, we will not make all the five philosophers to be seated on the table. It means that k minus 1 philosophers will be seated on the table. It means philosophers will be seated, and one table will be empty, so that the adjacent will not be waiting for the other adjacent philosopher will not be waiting for the other philosopher to drop down the chopsticks. Okay, that is the first solution. Okay, the second solution is, unless and until the both chopsticks have been picked by the philosopher, the philosophers will not start eating. It means that if he has taken the chopstick first, and then he should not wait for the second one. If the second one is busy, he has to drop the first one. Okay. If and only if the philosopher acquires both chopsticks, then only the philosopher has to eat. So this is the second solution. And the third solution is, the philosopher has to, whatever the five philosophers we have taken, right? The first four philosopher will pick left chopstick first and then the right chopstick. Okay, understood? So see here, how many chopsticks do we have? Five, right? The first four chopstick will first pick the left one and then the right one. And the last philosopher will pick the right one and then the left one. So this is the third solution. I hope you understood this one. Okay, the first solution, we're gonna choose k minus 1 philosopher. And the second solution is we gonna we the philosopher can eat if and only if he has acquired both the chopsticks. And the third solution is the first four solutions means if I have 10 philosophers, 9 philosophers, the first 9 philosophers will pick left chopstick first and then the right chopstick, and the last philosopher will take the last philosopher will take the means will pick the right chopstick first and the left chopstick followed by the left chopstick. Understood? So this is about the dining philosophers problem. And what is the little solutions which we can give using the semaphore? That is, we have used the weight operation and the signal operation. For acquiring this chopstick, we have used the weight, and for releasing the chopstick, we have used like we are saying them that I'm done with the chopstick, I'm done with the eating. So now you can take the chopstick. For that purpose, we are using the signal operation. I hope you have understood this. And one more problem, what problem we have arising is, let me share the same picture which I've shared the first one. See here in this diagram, for example, the C1, P1 needs C1 and C2. Okay, but C1 is used by P0. So what will happen? P1 might be P1 might be thinking like um P1 might be will be stopped in the first statement only. What is the first statement? We have seen weight of the C1, right? Weight of the chopstick I, right? So here when the first statement has been executed, in the first statement only the P1 is been waiting. When P1 is processing, this process or this philosopher has been preempted and the P2 started executing. Now the P2 will, what will happen? C2 is already acquired by P1. Now the P2 will see like P3 is acquired, now P2 is not there. So what it will do? He is also waiting, then immediately P2 is being preempted and the P3 enters. Now P3 has taken the C4 and it is waiting for C3. In the same way, all the processes are holding one chopstick and waiting for the other chopstick, which leads to the deadlock. To overcome this deadlocks, we have seen the three solutions which I have mentioned earlier. Okay, I hope you have understood this. Now we will see the monitors. What is a monitor and why the monitor has what is the purpose of the monitor, and how we are introducing a solution for the dining philosophers using the monitors. Okay, so here the semaphores should be in some sequence. Okay, to overcome the some errors, the monitors have been introduced. For example, after first weight mutex should be there, then the signal mutex should be there, right? So let me clear this one. Yes. First, the weight mutex should be there, then the signal mutex, right? For example, if I write weight mutex, then the weight, and again the weight mutex, is it right? No. It means that you are waiting and waiting, goes on waiting. That is wrong. That sequence is wrong. For example, if I write signal mutex and then the wait mutex, is it right? No. First, we have to wait for the process. Then we have to give a signal that I have used the process. Sorry, I have used the critical section of the semaphore, right? So the order, the sequence is very important. To overcome these kind of errors from the semaphores, the monitors have been introduced. Okay, now this monitors is a high level data abstraction tool, ADT, abstract data type. Here we have three things in the monitors. The first one is shared variables, the second one is operations, and the third one is initialization. Okay, the shared variables or the global variables or what we can say private variables, we will use these all things in the monitors. The second one, the operations, which will be performed in the procedure in the form of procedures, and the last one, initialization of the monitors, will be done using the construct. Okay, these are the three things which we gonna introduced in the monitors. Now we will see the basic syntax of the monitors. Okay, just a second. I will share the picture of that one. Yes, sorry. Just give a second. Yeah, I hope you can see the picture. I will zoom it. Yes. First, the monitors and the monitor and the we are giving a monitor name, and then we are using the shared variables, and for the operations we are using the procedures, n number of procedures, and then finally we are using the initialization code. It means that we are initializing the monitor using the construct. So we use a constructs for initializing the monitor. This is the basic monitor syntax. We use a monitor name, shared variables, and the procedures, and finally the initialization of the monitor using the construct. This is the basic syntax of the monitors. Okay, now we will see how the monitors are being used for what we say, how we are going to use it you for dining philosophers solution. Okay, earlier we have used semaphores, right? But we didn't get any proper solution in a code form, right? Now we will try to introduce in a programming language how to solve the dining philosophers. Okay, so at first I will share a picture so that you will get an idea of the program, and we will discuss the problem like C programming. Okay, let me share the photo. Just give me a second. Yes, I hope you can see the picture. I will zoom it. Yes, yes. I hope it's visible to you all. As we have learned, there will be a monitor name and the shade variable, and then what more the procedures, and finally the initialization, right? So here at first, we are taking the monitor name as dining philosophers, okay? And then the shade variables. These are the shade variables. These shade variables are being declared using the data type called as enum. Okay, so in this the variables are thinking, hungry, and eating. Now let me make it clear. The philosopher can be in thinking mode, or hungry mode, or eating mode. So here thinking is nothing but when philosopher doesn't want to eat, like he's not interested to eat. So he doesn't want the fork, right? So in thinking mode, the philosopher doesn't want to eat. In hungry mode, it means that he's very hungry. Now what he needs a fork, right? Eating mode is nothing but he acquired the forks and he started eating. Okay, these are the three states which we are mentioning in enum data type. Okay, and here state 5, this is we are indicating five philosophers. Okay, we are taking the five philosophers, right? And the next one is condition, condition self 5. Here we are declaring a condition, and which is called as self. Here the philosopher I can delay himself when he is hungry but is unable to obtain the chopsticks. For example, he is hungry now. He checked whether the both chopsticks are available or not. Okay, he got to know that the chopsticks are not available. So what he has to do? He's hungry. So he has to wait. He has to control himself, right? So for that purpose, we are using a condition variable. Means that you are hungry, I know, but the chopsticks are not available. So you have to wait for some time. So that's why we will use the condition variable, which is the condition variable name called as self. Okay. Here the condition variable wait will be there. The process will put in the suspended state. If it is a signal, a process will be resumed from the suspended state. Okay, now we will see What is the second section of the monitor? The operations, which will be performed in a procedure, right? So here the procedures, we are taking three procedures or three operations: pick up, pick down, and the test. This test are used in the void pickup and the pick put down, right? Okay, and the last in is initialization. Sorry, I didn't take that picture. I will explain you. Okay, initialization is the initialization code. In the initialization code, all mm, all the sorry, all the philosophers will be put in the form of thinking mode. At first, all the philosophers will be in the thinking mode, right? Yes, exactly. I hope you understood. I hope you're getting my point. I hope it's clear now. Okay. Sorry for the interruption. So I'm continuing the class before class. So here, previously, what we have taken in the monitors, the first we are giving the monitor name, then we are sharing the variables, and then we are giving the operations on the data, and finally we are initializing, right? So first we have given the monitor's name as a dining philosophers, and what are the shared variables we have used? Thinking, eating, and hungry, right? So these are the three variables which we're gonna use. These variables are declared using the data type called as enum. And we have used a condition variable which is called as self for the five philosophers, because if the philosopher is hungry and he is unable to eat because the both chopsticks are not available, at that state we say that the philosopher is in condition. Okay, so all the philosopher at first, they are in the thinking mode. They are not ready to eat. They are not ready. They are not hungry. So first, what we will do, we will initialize all the philosophers in the initialization code. We will make all the philosophers to be in the thinking mode, right? Thinking state. Okay, and um, I'll show the code. Just a second. Yes. I hope you can see the photo. So the initialization part I have explained, right? Now we will see the what the procedures or the operations. Okay, the operations are pick up and put down. Means we have to pick the chopstick and you have to put down. When you can pick up and when you can put down, we will write that code. Okay, so pick up, in the pickup code, first the state of the philosopher is what? Hungry. Because as he is hungry, he came to eat the food. How he can eat the food? Once he pick up the chopsticks. So we are saying that the philosopher is hungry. After that, he is testing whether the both chopsticks are available or not. Okay, so for that purpose, we have written a code called as test I. If true, if the test function executes; if it is false, the text function terminates. So let's see what is text here. Test here. So at first, it means that the right and the left chopsticks should be available, and also the present chopstick, the present philosopher should be hungry. That's what I've written here. The right should not be eating, the present philosopher should be hungry, and the left philosopher should not be eating. Then only the state of the present philosopher will be considered as eating. After eating, what he has to do? He has to tell that I'm done. I'm done. I'm done with eating. Okay. So I'm done with eating. He has to tell everyone that I'm done. I have finished the food. Okay. For example, if this test function is false, okay, it means this if condition is false, then what will happen? It will go to this line. It means a state of uh, present philosopher, for example, second is not eating, means this is false. Then what it will do? The philosopher will wait. That is what I have written here. The philosopher is waiting for the chopsticks. Okay. For example, if this is true, what will happen? The philosopher will start eating, right? He will eat, and after eating, what he has to do? He has to put down the chopstick that we have written in this put down. Okay? After putting down, he has to think, like he will be turning into the thinking mode again, and the right will it will inform to the right philosopher and the left philosopher. Okay, this is the code for the diners dining philosopher. Yes, this is the code for the dining philosopher solution using monitors. Okay, so let me be clear with the topics which I have discussed. First, first we have taken the first we have understood the problem, what is a dining philosopher's problem, and then we have seen what is it how the deadlock is been occurring in the dining philosophers, and then we have seen few solutions using few techniques like k minus one philosophers. We are considering, we are making to pick up both the chopstick, then only the philosopher has to eat, and or else the first four philosophers will be eaten left and then right, and the last philosopher will eat the right and the left. Okay, that is the solutions which for the deadlock. And the monitors we have discussed, the monitors, why the monitor is being introduced? Because to overcome the little bit errors which we are facing, the syntax errors or the sequence order errors, and we have seen the ADT. It's an like the monitor which is the monitor which is high level tool, abstraction tool. In that we have seen the three parts which are shared variables, and the second one is the uh, operations, and the third one is the and the third one is what um, and the third one is um and the third one is sorry um I'm so sorry. The third one is the initialization. Okay, these are the three things which we considered in the philosophers, like sorry, in the monitors. Fine. Next, we have seen the initialization. It's sorry, dining philosophers problem using the monitors. Okay, these are the different things we have learned in today's class. So I hope you are all understood these concepts. This will be very useful for your academic sections, or whenever you're facing the BTech exams, or else you can whenever you are attending any like competitive exams. These kind of the questions which you can face, like these are the important topics which you can understand easily and you can write in the exam. Okay, thank you everyone, thank you for listening to this video.